right, everybody. Thank you for joining today to PowerShell script design and how we can make this whole thing work to scale with our skills, with our team as our time goes on. Basically, today's session is all about being a gift to your future self so you don't have to hate your past self 2 years down the road. And that's totally not speaking from personal experience. So, first of all, before we really get rolling, many thanks to our sponsors that make that whole thing possible. We all wouldn't be here if it were not for that help, so thank you. A bit to myself, I'm a cloud solution architect at Microsoft. I'm called Fred, and PowerShell is kind of my thing. I've been doing this since I was a trainee when learning PowerShell was the first thing that turned me from a victim of Microsoft UI design into an actor that would allow me to fix my problems in a way that they would go away. Now, over the years, I have seen a lot of sins, especially my own, when I try to touch my own script. And, well, lots of customers throw their code at me, sometimes for PowerShell workshops, sometimes just some custom, let's clean this up thing. So I see a lot of scripts in the field. And I do believe I have a few solidly based opinions about what I do not want to see in a script. If you're more interested in that, I had 2 years ago for the virtual PSConfEU, the 7 deadly sins of PowerShell, where we cover some of the worst practices I've seen. Now, we are not going to do a PowerPoint battle here. This is about a script design, so if I don't do this in a script editor, I kind of would be doubting myself. But before we delve into the hands-on part, into the nightmare, and how we want to do it instead, what is the intended outcome today? I'm trying to show my process behind it, like the thoughts and the ideas that go into it before the first line of code ever happens, and how to evolve this into a script that is easy to read, that has very low tech requirements, so that when you go home from this conference, you can share this with your screen and team, and even onboard trainees and get them to do this. Like a minimal technical prerequisite to get started with a system that scales along as our technical skills grow until we reach the point that it's time to move that into a module and then make that move as painless as possible. All right, that's it for PowerPoint. Go away, you. Excellent. All right, we all have seen good scripts, bad scripts, horrible scripts, and those things that wake us up at 2 a.m. in the morning and wish us we could cleanse our memory. Now, before we go into how to do it good, I really want to show the dark side, why we really want to avoid this. The script that I'm about to show you is a script I had from a customer, which they allowed me to reuse for sessions and all kinds. The script is not actually bad. It does its job. But there are consequences of growing naturally or script design practices that lead to something that we really don't want to touch afterwards. So let's hope this works. So this script has a comment section. It's nice. We have some explanation here. Oh, actually, no, we don't have an explanation. We only have the file name, which is better than nothing. The file name tells us a few things. Another excellent thing, they provide the links to the sources of code that they reused. License management is a painful thing, and sometimes when we want to get at the original source, having that available is really awesome. The version history was not maintained, but that's nothing new. So let's move on with that. Arrow action preference stop is actually something I can strongly recommend for scripts that you intend to run and schedule tasks, so that's nice. We are checking for elevated, which can be done a bit more clearly than in this case. We'll be seeing that we've got a after the refactor file afterwards, so we will be seeing how that could be done better. One thing I must ask all of you, clear host is not something to put in your code. This is kind of like the user preference thing, and you're kind of killing all of the console history. So if your coworker runs the script and has some results from the previous commands, he might still be needing those commands, and killing that is a bad thing. Now, we are going to speed run through the script because we really don't have the time on all of it. It's more for like get an impression of things that could be going wrong. We set TLS 1.2. We use the equal symbol, which means we disable TLS 1.3. which is definitely a security feature. We could be doing instead something like this to ensure TLS 1 or 2 is available. Some logging, some gathering information that we don't need, specified a list. We're working with virtual machines here. We're trying to get some data from that, so we access a vCenter list, which, oh, wait a second, we're not using that. We're loading PS snap-ins, which is kind of deprecated in the year 2008. There's a VMware PowerShell module. Please do not use snap-ins unless there's absolutely no other way. We are loading credentials, which is great with some testing path. Loading the credentials then is never used. So we are loading sensitive secrets, probably virtual machine admin global, and then not using them. So I don't know whether that is something that should be in there. Some more data, commented out code. We might still be needing that 2 years down the road, so why not keep it in the script? There's something we call source control. I strongly recommend that. So, menu. Function with hard-coded message, so this function can possibly be used somewhere else. Some more pausing, because the pause command definitely does not exist in PowerShell. So we need to custom implement this. And some user input for more menu things with more clear host, because we're not cleaning up often enough. Hygiene is great. Yes, this is sarcasm. More data, more weird things. We now show the menu, ask for the input until the input is legal, and then we do more clear host set variable to make the refactoring extra spicy. Refactoring challenge mode. And, well, at some point down below, here we are now done. What did we do just now on all these 300 lines? We figured out which virtual machine to act against. And we needed to read every single line to figure out what it was doing. And we probably needed to reread it if we had enough time, because this was, oh my god. But it was doing the job, which is the key criteria for PowerShell scripts. If it's not doing its job, bad. If it's doing its job, I'm willing to forgive almost everything, not dynamic parameters. So we are finally ready, so we're clearing the host, just in case. Null comparison, okay, PS script analyzer, always helpful, tells us we kind of want this on the left side because of comparison issues, whatever. We are resolving the virtual machine list against actual virtual machines, avoiding perfect name matching, so we cannot be precise, but that's okay apparently. Fuzzy matching is a thing. And finally report that we found the VMs, and then we start producing data with more headers for the ticket message, that's nice. And then gathering a lot of information about each virtual machine, which is great. I mean, I might be using a hash table in this position, but it's still something. Gathering data to process it is not a sin. Only then we use write host to write it on the screen. Then for each disk, we use add member and objects. Please do not use this. PS custom object is great. Also easier to read and a lot better performance. And array addition, please don't. Next performance issue, but we don't have the time to spend on all of the performance details in here. We go through all of the HED stats, more information on the snapshots. And finally, we have an else, in case we still remember what the if was all about. And hey, then we have some more commented out code because who needs that? And then ding, 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 reporting our script is done. Now, this script does its job. It informs the virtual machine admin whether there's still enough storage for whatever they're planning to do, which is great. From a design perspective, this requires us to read the entire script from top to bottom to even figure out what it is about. Until that last part here, we didn't even know what we were doing with the data. So we couldn't skip any single thing. So if you've got a script in production, it's running for 1 year, and then it fails with an error, and you get an error in line 599. Well, congratulations. Now you need to first read the first 598 lines before you realize what is the context where we're failing just now. From a design perspective, there is one key thing that I want to point out, which is easily lost in all of this forest of signals here. The script presents a lot of data. It does not perform the analysis. The script was about, do I have enough storage? But nowhere in there will you find I have enough storage. You will only see I'm using this much storage for this VM disk, I'm using this much storage for this VM disk, and then you need to figure it out yourself. If you already have the data, please don't stop before you do the analysis. So at some point, the script is done, and I paid heavily in order to be able to reuse the script for workshops and for conferences. I paid and I'm having to rewrite it. So let's take the same script and look at how it works after it went through my process that we will, after that, after we've seen things, go through and how we reach that point, especially from a greenfield, but also for brownfield code that we need to refactor. So we have a parent block. For our scripts, we do not hard code information. If we somehow can avoid that, that's great. Validating input as the parameter binding is also useful if you want to understand why and where and how. There's tomorrow a call on parameter binding where I'm going to be spending a lot of time and going to the innards of parameter binding. That one is going to be a bit more brain melty when it comes to technical complexity. Fair warning. So other than warning, we have here requires run as administrator. This single line tells the script you need to run as administrator or don't run. And it doesn't do anything before that, so this is the cleanest way I know of to ensure that elevation requirements is noted. Since this was a rewrite and I wasn't allowed to bring in new modules, I also had to require the PS snap-ins, which means it doesn't work in PowerShell 7. Help, great thing, please write it. That said, we have some default paraphernalia to some tools to make the error handling sure, because in PowerShell, errors sometimes only happen when they are in a try-catch statement, and I want to keep everything below clean, so I do a trap at the beginning of the script, which is kind of like a global try-catch statement. Make sure like logging is concluded and everything is done, clean up, and then I rethrow the error, which makes sure that task scheduler or other runner agents realize the task failed. So we have some neat little lines of functions which we're hiding because they don't matter, and this is now our entire script as we care about it. That is all there is to this entire rewrite, really. We can now figure out in these 8 lines what's actually happening in the script. What is it doing? What is the workflow? What am I trying to achieve simply by using clean naming and providing that logic bit? It also means we now have a lot of functionality parceled out into individual functions, which we can then reuse for the next script. For example, figuring out which virtual machines do I need to process. This is something as a virtual machine admin I'm going to need more than once. And with that, I can just pick those functions up and get somewhere. So let's see the first one. We have getVMList. GetVMList is there. We now support paths, so it's no longer mandatory interactive. The admin can run the script with parameters and is not being prompted for anything. Don't let people prompt you. And if those are provided, we simply end the function here after we process the data and are done. Now, the original script was supposed to allow the user to provide a file with the VM names. So asking them for a file path is annoying. So what we did instead, after asking the user what they wanted to do, is we have a show open file dialog, which uses the UI elements to pick a file. A lot more user-friendly. And this function has absolutely no dependencies outside. It's just doing this one job. I can copy-paste it in any other script that I want or put it into a utility module and reuse it. So I've broken down the individual steps into isolated commands that are as reusable as possible through parameters, and then I can just plug and play them elsewhere. As in that one. Let's see whether that works right well, or whether the demo gods are benign today. And come on, you can do it. Yes, code, I know. I know we have a history here. I know I've not always been kind to you. I mean, you deserved it, but still. Okay, I'm just gonna have to skip that particular part. The editor is currently in league with the demo gods. So let's drop that. By the way, this is all going to be on GitHub, so if you see, oh, great, open file dialog, I want that for my own scripts, you can totally copy-paste that. So we have this part, we have the entire layout here somehow. So how do we get there? How do we start, especially when we just have a task and want to get this done? How do we make that happen? Especially if we are not PowerShell experts with 10 years of experience, and instead, for example, the trainee that has gotten the first job from you to actually start coding. And he's got Google, he's got ChatGPT, and he has an empty editor, possibly still the ISE. I strongly recommend moving them to VS Code because VS Code helps with a lot of things thanks to PS Script Analyzer by now. But we have an empty field, and let's wrap this whole thing up into a story. Something that tells the entire narrative. Life is a text exercise. It's not a sterile 1 + 2 = 4. Disprove me. So we are starting on a new job. We got freshly hired as a new DBA, SQL admin, for a company. They do have an old DBA. He is 62 years old, and he's approaching retirement, and they want to have a sufficient handover time to make this whole thing work. So it's supposed to be a soft landing. First day of the work, you arrive at the office. Again, you still remember it from the interview, so you find your way. And your table is already ready for you, but the table of that senior that is supposed to help you transition is kind of cleaned up. What happened? Okay, setting things up, and the boss is coming over. Fred, glad you're here. Sorry, Fred, I have bad news for you. You know about Max, who was supposed to help you get started? Well, he was easy-kite by a truck and is currently busy fighting the demon lord, so he doesn't have time anymore. So yeah, accidents happen. He's gone, but don't worry, he's got the documentation ready. Find your place. So, okay, you now have 2 office seats for yourself. I mean, that's already something. More space does really hurt. You open the cupboard with the documentation binders. They're kind of dusty. You open it from year 1998. Thank you, Max. Putting that back. Logging onto the share. There are a few more project documentations, only 3 years old, so that's somewhat better. But well, there's no burning emergency, so no problem. You settle down. Get started. A few more minutes pass by, and the boss is back. Sweat is running down his cheeks. He's kind of nervous. And Fred, we have a slight problem. I just got a call, and we've got a Microsoft licensing audit coming, and I need a report of all the SQL servers in the domain. I'm sure the documentation is okay-ish, but let's be honest, we both know it's an issue. How fast do you think can you get this done? So that's where our script now starts. As soon as VS Code is happy with stopping screwing with me, okay, I'm gonna use the big evil trash button. This is totally not symbolic. Yes, 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 VS Code, I love you. Worked. And there we go. You've got a clear screen of nothing. Yeah, that's great. So we have a task. We need to get this somehow done. Let's get started by not coding. Instead, I'm asking 3 cardinal questions. Question number 1. What information does my script need to even start? A lot of information we can auto-detect. We don't need a literal list of every single computer, but we need some information to get this script going. The second question, what steps do I need to take? Now, this is obviously the price question, where we'll be spending a lot of time in the details somewhere. But we are not done yet, and that third question is really, really the most important part of this entire show. And I see so many times where we don't answer this question. What is our outcome? And I process these questions in reverse order. So let's start. What is our outcome? Any proposals?
The number of licenses needed.
We have a report from here, a number of licenses from here. That's good. The problem, as we now talk with our boss, of course, what exactly does he need here? And the number of licenses is something that is definitely the end result of the analysis, but we need a bit more data, and we need to provide the data because the auditor wants to review that, not just on trust that we need this many numbers. Report, yes, we need a report, but that's a bit abstract. A list of SQL servers. That is something we really would like. The problem is our documentation is 3 years old, so we can't rely on that list's accuracy.
Yeah, but that's the outcome. That's the outcome.
That's the outcome.
Computer, instance, edition, number of cores.
All right, here we've got a few really good answers, good propositions. We need the information, not just what data is on a report, because we make assumptions about what, hey, this is a report, now I'm assuming something, and I'm building my entire script along that assumption. Big surprise, for a SQL Server licensing report, I need the number of cores of the hosting VM host. This is if we're just looking at virtual machine and give me the SQL Server installed, we're missing a major part of the script by the time we submit it. So, exact fields of information. And the next part, report. Report is a nice thing. Report means different things for different people. For me, that is usually something like a CSV file. What if my manager expects a lively synced Power BI report and a dashboard? If the boss is from accounting, that is not so absurd. They might want a complex pivot table. They might need these kinds of information. Some of them are very easy to deal with. Some of them need us to re-engineer the entire script. So clarifying those assumptions at the beginning can save us a lot of time. And it is the step, myself included. Many admins kind of skip for now because they know enough to get started. So that is our outcome. Now, what steps do we need? Any brave person with a suggestion on that? The first thing, we don't have a reliable list that we can trust. We don't have any specific details. With a bit of background information on how SQL servers work, we cannot rely on them being listed in Active Directory. Because, yes, I can register as SPN, a service principal name in AD, but there's nothing forcing me to do so. So, first of all, identify computers to scan. Then we go with the next step for each of them. Perform scan and generate data. And finally, when we're done, the most important part of the whole thing, write the report. Now, this is, again, something where I tend to rush into developer tunnel vision. The key part about the planning steps here is what do I need to do, not how do I do it. So many people, when I do this in a smaller section where it's more of a dialogue, start telling me, okay, now I'm going to remote it to the computer, when we're still in the planning phase of what we're planning to be doing. And that's easily happens because as engineers, as technicians, how do we do this is kind of core of our daily activity. It's where our soul is at, where we love to just going ahead and executing and solving the problem and then on to the next and the next. It gives us a feeling of accomplishment. It's a key part of a motivation cycle, so it also tends to be a key part of how we get started with a new script. So please don't step right into the details. We'll be moving later on in how this really makes our script more convenient. So we need we've got one more question open. What information does the script need?
Which domain?
Okay, very good answers, all in the same vein. Yes, which domain is the first one that we kind of need as input. I mean, we can make the assumption current user domain by default, but not every on-prem Active Directory environment is single domain.
Plus the list of workgroup servers. Some of them being Linux servers.
Possibly, yes, let's add that here. Additional computers to scan.
Which credentials?
Credentials, excellent. At some point, we need to look into a computer to see whether it's a SQL server. There is a easy way to operate a SQL server without any outward signs, simply by not opening the firewall. It's serving an application on the same machine. Why would it need any outward connectivity? So yes, credentials, we need to look into the bloody machines. There's one critical, absolutely critical piece of information still missing.
Network zone?
Mm-mm.
The vCenter? Where you want to
Nope. That we can try to auto-determine. No. Without that, it's going to be kind of difficult to generate that report. All right. We are now done with the planning phase. We are now good to get started with messing with actual code. One key thing about this plan so far, this is not the 10 commandments of Moses. We are free to later adjust this based on our recognition that our initial assumptions were not quite correct about what steps do I need to take. What information do I need? Going back and updating it is perfectly fine. There is no sin, there is no morality questions here. We are not talking about scope boundary violations or something like that. This is all about a mental exercise we do to make sure that we have a clear path, a clear code, a clear goal in mind, and to try to get rid of our assumptions. So we are now good to go. Let's start. I go as usual with a, okay, no Fred, that was, yeah. Typing the right thing will work better for you, Fred. So let's try doing that. And if you use your snippets, that actually works even better. So we have a domain. Let's go for now with a single domain. It's going to be a string type. And we're going to be rational about it. We make a default value, user DNS domain, and are good to go. So we have somebody who absolutely wants additional computer name to make our task more complicated. No worries, we can do that. So we have a PS credential object for the credentials. And finally, we have an out path. I'm not going to add any of the additional complexities like parameter validation here. This is something nice to have, but it is not critical to the entire process. Because let's be honest, if I give a trainee this task, he is going to be very head-scratchy if I'm telling he needs to have a validate script running there. I mean, it would be a great learning experience, but it's not the way to start his first script. So we have the default copy-paste error action preference and the trap statement. I'm just going to go write warning, assume you have instead logging, and make sure the failure is logged and the log is properly flashed and all that. And refrow the error to make sure the script fails properly. Then we add a nice little region called functions, or whatever name works for you. The name is less important than the content. And then we are good to go and get started with our entire script. Get domain computer, domain, credential. We might not have a trust between domains. And that extra parameter, that's going to give us the extra computer. Now, this command is nice. It's going to give us all the information that we need. Great. And finally, let's not go with pipeline, write SQL instance report data instances path path. Our script is ready. Okay, now it would be nice if all of these commands here actually exist just like that. And actually, there is a command to find the, SQL instances in DBA tools, which as a module I can strongly recommend if you deal with SQL servers and need to automate them. MS SQL servers. But other than that, the implementation detail is now something we have to, of course, deal with ourselves. So we go ahead and do that. And have to go and do the hard work. But now we have broken down the complex problem into individual steps. That trainee that is writing his first script, that trainee might not be able to manage get SQL Server instance, but a command to get domain computer, this is something you can get ChatGPT to give you. This is something you can go to Google for. This is something you can find in the TechNet library if you go to the Internet archives. It's there. This problem has been solved so many times. This is something you can manage. So we break problems down. We look at them in isolations and have less complex problems to solve. By breaking it down this way, we also are more likely to produce reusable commands. And we get better questions from that trainee and other co-workers that are now trying to use this, because they have first broken it down, thought about the process, and are a lot more specific in asking for help. It's not, can you write the script for me anymore? It now is, can you tell me how to do X, Y, Z? That takes less time for me. It makes me a lot more willing to help, willing to spend the time on it. And since they're now solving individual smaller problems, it's a lot more likely that they're not giving up, or that they are more able to learn from this and better able to reuse it somewhere else, leading to faster success and accelerating the learning cycle. Which leads us to a few remaining problems on this whole thing. And the key problem that most trainees will now face is, that's nice that you managed to do all this, but how the hell do I figure out what these steps are? I mean, this guy's coming fresh from the Berufsschule. He's doing his first coding. He's kind of confused, looking at me, staring at, am I leading him into the slaughter? Am I trying to sacrifice his firstborn right now? I'm asking him to do PowerShell. And I can tell him those 3 steps, and he thinks like, yeah, great, now, this process sounds survivable, but how the hell do I get there? And the problem is, there is no golden bullet here. We can try to guide them. There is usually no way around a certain level of knowledge about the product that you're trying to automate against. There is, however, 2 procedures I've put together that work fairly well to help self-start to figure that out and apply it to many, many problems. It's not a universal solution, but they tend to leave people less lost in the forest, wondering where is the exit. Approach number 1. Use the UI steps. You do it manually. You have steps that you need to do manually. It's like a cooking recipe. Write those steps down. Congratulations, that's your first attempt there. On the plus side, this is very, very graspable in the most literal way we can do in IT. On the downside, this leads to sub-ideal code, because PowerShell allows us to enable things. And it does not mesh too well with the approaches, because most of those steps are already in the why region and less in the what region. So it's not ideal, but it is something that can work for simpler problems. For example, let's imagine a task is not find all SQL servers, but shut this one virtual machine down. This is something that would translate really well when you do the UI steps and then try to script that out. we wouldn't need many custom commands as well. We literally have restart computer to get the job done. But yeah, that works, but it is limited. Option 2 is something I call the 4 phases. I have number 1, figure out the targets that we need to work with. Identify the targets. Where do we need to go? Step number 2, gather all the intelligence, all the information need to execute. We don't only process, prepare everything so we're ready to go, but we don't do anything yet. The third one is kind of simple then, at that point. And the final one, which is sometimes not all that necessary, is the report part, if we need some action of what happened. In this case, the report is our result, so 3 and 4 are the same thing, but there are different aspects to that whole thing. For example, let's say I have a user migration. I have an Active Directory user that is supposed to have voice enabled from Skype for Business to Microsoft Teams. This requires us to gather Active Directory information, update the information on that Active Directory object, wait until replication in the cloud is done, and then execute the policy setting steps on Teams. So now we need to gather first data in which phase is this user, what has happened, in order to be able to determine what are the next steps for that user. And in that case, having a report at the end, like I modified this user, I just changed something, especially when it comes to telephony, which is something every user will immediately notice when it fails. Having a clear track of what executed, that's where reporting comes in really, really handy. And that is my entire approach to the whole thing. I write to this day every single script that way. And it usually helps me avoid having to go back and modify things and refix things, because it forces me to first begin considering what are the actual steps that I need, and makes it a lot clearer from a path perspective. Now, for posterity, I have this whole thing in a repository. If you want to look this up later, this is the thing to photograph. It's going to be public by the end of today. And one more thing, in that repository, you will also find a markdown part file that a lot more in depth explains the individual phases, kind of like a notes to the voice line, among other things, in case I kind of forgot a few of the details in the middle of talking about some personal nightmare or some scripting bad practices. Or, you know how I am. I kind of can get lost in some of my narratives, so having some backup for that in case of emergency seemed like a good idea. So we now have here a concept thing that explains the whole thing in more detail. Some notes for people that for things I've seen that people adopt from this that I strongly advise against. We have here the section of things that we're doing, the steps, the main logic. Please do not include comments. Do not include write host, write verbals, write log, even write PSF message. I mean, I strongly recommend that command everywhere else in the code, but not here. If the names of your commands don't speak enough for themselves that you need comments on this, you need better names. If you need to explain the logic more, why you are taking those steps, there is something nice called documentation with a description file. This part has plenty of space to put down your thoughts on this whole thing if you want to explain more why you decided to do something. Do not use the main logic for that kind of thing. Another benefit from a technical deep dive perspective, when we break this down into all of these functions rather than that one nightmare script, we have something called the script stack trace in an error object, which allows us to clearly identify in which phase, in which subphase, in which substep things actually broke. So it makes it even easier just from a debugging perspective. So that is my entire content for this. My approach works really well for me. I have some long-term customers where they unleashed me on their poor trainees, which, yes, this trainee thing was not from somewhere. And one of them is probably going to be visiting us at PSConfEU next year. At least I'm trying to bug him into finally go ahead and submit his bloody sessions. He was still resistant. Questions? Yes?
Do you have any tips? Because for us, we don't need usually to rewrite our scripts based on not correctly coded and so on, but most on performance issue.
All right.
Too much CPU resources or memory.
All right. We've got a question about whether I have any tips on optimizing script performance, notably with a look at memory consumption. Yes, but it's kind of a bit out of scope, but we still have to have a few minutes on that one. Try to avoid caching, use the pipeline. As long as you do not interrupt the pipeline, you usually have only one object or one page in memory at the same time. You can use select object to cut away information. You can technically outsource your data into database or other storage or even to file if it is a valid option. Usually that comes as a performance cost, since then now you need to read again. If it's something high scaling, very important, performance sensitive, use a SQL instance of some kind, whether your own or your hosted instance in the cloud, because that way you can do server-side indexing and filtering, because the cost of outsourcing the data means you now need to retrieve it somehow, and that can be expensive. When you export that into a file, it usually means you need to load the entire file again in order to be able to sort it out properly. So, yeah. That's what I really have from a memory perspective. Another thing you can do when you get a lot of information via PowerShell remoting from remote systems, don't for each loop invoke command. It forces it into doing sequentially rather than parallel. And when you use a PowerShell remoting session, you can leave the data on the remote session. And iterative steps reuse that data. You don't need to send the data to your local machine and back again, and to your local machine and back again, and to your local machine and back again. Other than that, anything I can say will basically be a session all by itself, which I might submit for next year. Well, if there's nothing else, you know where to find me. Anywhere there's PowerShell. Okay, not quite here. We have a target-rich environment where that's concerned. But hunt me up anywhere in the conference. One thing people that know me realize, it's a lot easier to get me to start talking rather than to stop talking.